As the well is dug, it may penetrate rock layers which serve as a resource for drinking water. If a shallow well stopped at this depth, then there would clearly be a mixing of chemicals and the natural gas produced with the drinking water, which would contaminate the drinking water. And so the overwhelming majority of these hydraulic fracturing sites would dig far deeper so that there is a considerable distance which separates the targeted rock formation, where the chemicals will mix with the rock layers and fissures in the rock will liberate natural gas and the resource for drinking water. This vertical separation distance varies from well to well, but is typically thousands of feet. So, in this ideal setting, there would be no contamination of drinking water because of the great separation distance between the targeted rock formation and the drinking water resource. However, there are a number of scenarios in which the drinking water can be contaminated, but this is more a problem in the materials used in the hydraulic fracturing rather than the process of targeting this very deep rock layer itself. So, for example, there may be cracks in the casing or tubing which is used, which would liberate materials into the drinking water. There may be no cement used, and thus there would be spaces between portions of casing through which chemicals may be released. There may be a space between the casing and the cement, or a space between the cement and the rock layer, which would allow some escape of materials. There may be cracks in the cement, especially if it is a poor quality. And so it is certainly known that hydraulic fracturing sites can contaminate groundwater, and there are a number of these materials aspects which might contribute to that. Thus, best practices could minimize the effects of this chemical loss if better casing, tubing, and cement practices were employed.